So in this problem, we're going to look at a very basic set of Kirchhoff's voltage law and then Ohm's law as well. So what we have in this problem, we have a 24 volt source, direct current. We have a 3 ohm resistor here, a 7 ohm resistor, and a 2 ohm. The problem is asking us to solve for V1, V5, and V2. So again, what this is saying is these are the voltage drops over those resistors. So here we have a voltage drop because of the resistor taking power out of the system. So if we took one piece of our multimeter and put it here, and another piece here, and took the absolute value of that, when we subtract the two, we're going to get V2. And that's going to be the voltage difference between these 2 points. So this correlates to how voltage and actually how power is removed from the system. So the first step that we have for this one is we have to do our Kirchhoff's voltage law, which is the sources minus the sinks. So for this one we have a 24 volt source minus the voltage V2 here minus V2 minus V5, V5 minus V1. And these are just arbitrarily numbered. This doesn't mean anything whatsoever. So what we have here, if we're going around the loop, we're going to have 24 minus V2, which is this one, minus V5, which is this one, minus V1, and that's going to equal 0 because we're in one loop. So the next step we're going to do is use Ohm's law, which V equals IR, and we're going to substitute Ohm's law into these V's that we don't know about. So again, we have 24, and we're going to keep the volt out now because we know it's in volts, minus V2, V equals IR, and our R equals 3 ohms. So we don't know what our I is yet, but we're going to keep that there. I, and then 3 ohms for that, minus, and again, we're going to have our V equals IR because we don't know what V5 is. And that's going to be 7 ohms times the I again, so I times 7. And now we're going to have, again for this last one, we're going to have 2 ohms, and we're going to use the same little formula, V equals IR, because we don't know what V1 is. So we're going to plug in I times 2 here, equals 0. So now, since we have I, all of these I's are the same because we have one loop. There's no nodes where current is branching off. Everything is together. So therefore, we're going to have we're going to be able to solve for I right there. So another way that we could have done this, which is just as easy, is to take our V total equals I total times R total. And so our V total is again 24 volts, 24 equals our I total. We don't know that yet. I total, and then we have our R total, which these are all in series, and therefore they all add together. So we have 3 and 7 is 10, 2, so 12 ohms of resistance. So therefore, I total equals 24 divided by 12 equals 2 amps. So using that, we can solve it into here just to check, and we're going to get this, which is V2. So V2 is going to equal 6 volts, excuse me. Correct? Yeah, 2 goes in, 6 volts for V2. So this is going to equal 6 volts. We have our I7, so we take our 2, we plug it in here. That's going to be 14 volts, and that's going to equal over our V5. So V5 is going to equal 14 volts. And then we have again our 2 times 2, so that's going to be 4 volts over this one, so V1 equals 4 volts. And if we subtract these together, 24 minus 6 minus 14 minus 4 is going to equal 24 volts. So that, equals 0 volts, excuse me. So this equals 24 and this is 24. 24 minus 24 equals 0. So we know that this is a valid solution. So now the last part of the problem, since we've solved all of this, we know the V2 equals 6, we know the V5 equals 14, we know the V1 equals 4, and we know the current, which we called here I5, or I because there's only one thing, the current is going to equal 2. So the last part of this problem we want to know is what is the power delivered to this? So power in equals power out, but right now just what is the power? delivered by this source. So the power, again, equals P equals IV. So we're going to have power equals the total current, which is 2 amps, times the total voltage, which is equal 24, equals 48, and the units of that is watts. 48 watts. And so that's how we solve this type of problem.